Alright, so I've been asked to do what is on the honors final exam practice version, number 137, and that corresponds to number 139 on the CP practice exam. And it says, what is the percent of oxygen in dinitrogen pentoxide? So dinitrogen is N2, pentoxide is O5. Okay, so what we want then is the percent of oxygen. When you say percent and you don't specify what units of measurement were used to measure to start with, the implication is always the same. It's that your measurement units were grams to start with. Okay, so what we're going to do is calculate molar mass. Okay, to find the mass of oxygen in the same mass of the whole thing, and what we're looking at is the mass in a mole. Okay, so let's do that. Everybody do that with me. Don't just sit up there and watch me do it and expect me to do it for you while you are a passive learner. We don't want any passive learners in here. We want active learners in here. So you should have a piece of paper and a pencil and a calculator doing this. I know some of you may have done it already, but come on, work with me here. So in an honors class, we use a different periodic table than CP, but the process is kind of the same. You're just using it, starting out with different numbers. Okay, slightly different, not really different numbers. The honors class periodic table is slightly rounded off, has slightly rounded off numbers. So I'm going to start with 14.01. In an honors class, it'd be 14.0107, I think it is. I'm sorry, 14.0067. Okay, so anyway, we've got two of these, and oxygen on the AP version of the test references, which we use in honors chemistry, is 16.00, and we have 5 of those. And so we're going to find out what multiplying 2 of these together is. Well, I can do that in my head. 28.02, and this is going to be 32.00. Okay? Then we're going to add all these together. The definition of molar mass is the sum of all the atomic masses, that's what these numbers are, of all the atoms in a formula. So we multiply those together. Well, multiplication is just another form of addition. It's like repeated addition. Yes? Oh, 5. Well, okay, then I got to do that. Okay, so 5 times 3 is 30. I don't know why I did it by 2. And then that'd be 80, right? Okay. So then we want 108.202. Is that right? All right. Now the way we've done this using the honors references, there's no rounding off to be done. When you don't have any empty slots to the right, in addition, there's no reason to round off any digits. What we have to do, though, is to write out our units of measurement. So these are the grams of N2O5 that equals 1 mole of N2O5. O5, okay? Well, this number here, by doing it this way, this number here is the grams of nitrogen in 1 mole of N2O5. I can't say they're equal because they're not equal, but that's the mass of nitrogen in that, right? Now these two are equal, 1 mole of N2O5, 1 mole of N2O5, so we're looking at 1 mole of N2O5. This mass here is the mass of oxygen in 1 mole of N2O5. So in this mass of N2O5, because it is 1 mole, you have this mass of oxygen and this mass of nitrogen. So by doing molar mass the way I've taught you to do in this class, you kind of get the data you need for something like this pretty quickly. Well, the percent then is going to be 2 different percents. You've got to have a percent of nitrogen and the percent of oxygen. You got to, if it just says find the percent composition, you need the percent of each element in the formula. If you've got 12 elements, you're going to have to do 12%. Yeah, I don't think there's any formulas I can think of that's going to have 12 elements, but it could be one somewhere. So let's see, we're going to take 28.02 grams of nitrogen and 108.02 grams of N2O5. Percents are always times 100. Okay, notice the units cancel. Now, not every percent cancels the species, but every percent should cancel the grams. What? I got to find out both of them. Or that's just for oxygen in the question? Okay, well, that's how you find it for that. So if we're just finding oxygen, then we take 16.00 grams of oxygen over 108.0, huh? Oh, why did I do that again? Gracious help me. All right, let's see, 02 grams of N2O5 times 100, maybe slightly less than 80%. So I get 74.060,359.19. We are going to cancel the units, but not the species, because oxygen doesn't cancel out N2O5. We need 4 digits, and our final answer, 1, 2, 3, 4. So our percentage is going to be 74.06% oxygen in N2O5. Does that make sense? I don't hear anybody saying no or yes, for that matter. I guess it makes sense.